You are welcome to Dorea Express. So today we'll be looking at naming of bicyclo compounds. So from the name we see bi and cyclo. So bi simply means two, and cyclo comes from the word cyclic. So it is simply naming of a compound with two rings. So we are going to take this as an example. So let us write this out. As you can see, this is a carbon. We have a carbon here. 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 We have a carbon here, 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 here. So this is what this simply means. And here we have a chloride group attached to this place. Here we have CH3, a methyl group. We have another methyl group here. I have a methyl group here too. So this will now be CH2. This will be CH2. This will be CH. This will be CH. So this is what we have. So the first thing to do in naming bicyclo compound is to identify the head bridge. If you look at these two cyclic compounds as rivers, you will see that this is a bridge. It is a river, for example, this is a bridge. So this is the head bridge. We start naming from the head bridge. So we move around the ring starting from the head bridge. So in this case, this is a head bridge. This is another head bridge. So it's either we start from this head bridge and we start from this head bridge. So the head bridge having a group attached to it will be where we will start from. If you look at these two head bridge now, this has a methyl group attached to it. So we'll start from here. Another decision to take is, are we going to follow this direction or follow this direction in naming this bicyclo compound? So if you look at it, we have another group in this place, in this direction, and this place is free. We don't have a chloride group here. So we will follow this direction in naming this compound. So let's look at it. This is 1. This is our 1, our 2, our 3, 4, 5, 6, and 7. As you can see, we started from here because we did not start from here because this has a group attached to it. So we follow this way because this way there is no group. If you look at this methyl group, this methyl group is farther, but this one is close. So we follow this way. So we name it 1, 2, 3, 4, 5, 6, and 7. So the first thing to do is to identify the substituent attached to the bicyclo compound. So let's start. We can see a methyl group. At the first, the 5th, and the 7th position in this ring. We can also see a chloride group. A chloride group at the 2nd position. So the next thing to do is to start naming, starting from the substituent attached to the bicyclo compound. So if you look at C and you look at M, C comes first in the alphabet. C comes before M. So we start with C. So this compound is now 2-chloro, then we go with the methyl group 1, 5, 7, tri-methyl. Then we write bicyclo. So we open square brackets. So what are we going to write in this square bracket? We look at the head bridge. Apart from the head bridge, how many carbon do you see on this side? And how many carbon do you see on this side? Let's take this, because this will be more simplified. Apart from this head bridge here, you can see that we have 2 carbons and we have 2 carbons here. So it will now be 2, 2. It will be 2 2. Then let's look at the head bridge. Is there any carbon? We have a carbon here, so this is a carbon. It will now be 221. 221. Then we look at how many carbons do we have generally. 7. 7 is het, so it will be heptane. So the name of this compound generally is 2-chloro 1,5,7 trimethyl bicyclo 2,2,1 heptane. So let's look at another example. So let's look at this example. As we say in the rule, the first step to do is to identify the head bridge. So as you can see, this is our head bridge. This carbon here and this carbon here is our head bridge. So let's look at it. Are we going to start from here, or we are going to start from here? So let's see. If we are starting from here, we'll have 1, 2, 3, 4, 5, 6, 7. So as you can see, the chloro will be on the 3, on the third position. But if you go this way, it will be 1, 2. So we give preference to the lowest number, to the head bridge. So we'll follow this way, because this will give us 1 and this will give us 3 if we go this way. So this is the head bridge. So this will be our 1, our 2, our 3, 4, 5, 6, 7. So whenever you see a line bent, it indicates that there is a carbon there. For example, we see a line like this. This is trying to tell you that we have a carbon here, we have a carbon here. If you see something like this, it's trying to tell you that there's a carbon here, there's a carbon here, and there's a carbon here. So in this case, we have this point, which is telling us that there's a carbon. But if you see something straight like this, it simply means there is no carbon in the head bridge. So let's continue. So in naming this compound, we have identified our head bridge and we have numbered the compound. So let's look at the groups attached to the carbon. As you can see, we have only one group, which is chloro, attached at the second position. So in naming this compound, we say 2-chloro. So no other substituent attached to the ring. So we say this is 2-chloro bicyclo. Then this point, when we are writing the numbers in this square bracket, we don't count the head bridge. If you look at it, this is the head bridge. We are not counting here, or we are not counting here. We are only looking at these carbons here. So as you can see, we have 2 carbons here. We also have 2 carbons here. That is 2, 2, and we have 1 carbon in the head bridge. If there is no carbon in the head bridge, if you just a straight line like this, meaning there is no carbon, we'll just put 0 here. But since there's a bent, it is bent, it simply means there is a carbon here. So in this place we have 1. We have 1. So and we have a total of 7, which is what? Heptane. So the name of this compound is by 2-chloro bicyclo 2,2,1 heptane. So let's look at another example. So let's look at this example. This is a bicyclo compound. So the first step is to identify the head bridge. In this case, this is our head bridge. So we can decide to start naming from either here or here. And we follow the longest carbon chain, just like how you name your organic compound. In organic chemistry, you follow the longest carbon chain. So in this case, we can follow here and we can follow here. And if you look at this case, we can follow any of the sides because we don't have any substituents attached to this ring. Assuming we have something like Cl here now, we will follow here. But since we don't have anything, we can decide to follow any place. And if you look at this compound closely, you will see that there is a carbon here. This is a carbon. And whenever you see a carbon like this, and you see just a line, it simply means this is another carbon here. So this is what? This is a methyl group, CH3. This is a CH3 group. But if you see something like this is the intersection here, and you see something like this, it simply means this is a carbon and this is another carbon. So it is C2H5. Like group. So that's another thing you need to know. So as we can see, we have two substituents in this group. That's two methyl substituents. So let's number the carbon chain, the bicyclo. This is 1, 2, 3, 4, 5, 6, 7. So this is 7. And we have methyl group. We have methyl group. We have a methyl group. So, and this methyl group is at the 7th position. So it will be 7, 7 dimethyl bicyclo. So this is what? Ignoring the head bridge, we have 1, 2, 3, 4 carbons here. This is 4. We have a carbon here, 1, and we have no carbon in the head bridge, 0, heptane. Let me write it down here, heptane. So this is 7, 7, 7 dimethyl bicyclo 4, 1, 2, 3, 4, 1, 1, 0, heptane. So let's look at the last example for this series.
Come and see this one.
So you can see this example. This is a very critical example. It is different from the examples that have been seen before, because in this case we have a carboxyl group, which is a ketone. We have a carboxyl group here, and we have two methyl groups in the head bridge. So let's identify the head bridge. As we said earlier, this is the head bridge. This point, this is the head bridge. So we may start numbering from here, and we may start numbering from here. So as you can see, there's a substituent in this side of the ring. So it's telling us that we must follow this direction. We can't follow this path. We follow this path because there's a substituent. So another question that comes to our mind is that, do we follow here or we follow here? So let's look at it. If we number from here, this is 1, 2, 3. So we can see that the ketone group, that the ketone is at the number 3 position. But if we number from here 1, 2, 3, we'll see that the ketone group is at the number 2 position. So we go with number 2 because we follow the shortest path. So we are going to number it this way instead of numbering it the other way around. So let's number it before we name this compound. So this is 1, this is 1, this is 2, this is 3, 4, 5, 6, 7. So let's look at the substituents we have. We have a methyl group at the 7th position, and we also have a ketone. We have a methyl group at the 7th position, and we also have a ketone. So the next thing we are going to do, we start numbering it. This will now be, as you can see, this example will be different from the examples we have been doing before because we have a ketone group in this case. So this will now be. So let's look at this final example. As you can see, this case is different because we have a carboxyl group here. So we start numbering from the head bridge, like the first rule say, identify the head bridge. So this is the head bridge, and of course we cannot go this way because we have a substituent. So we go this way. It's either we go this way or we go this way. That's from this head bridge or from this head bridge. So let's see if we go from here. This will be 1, 2, 3. 1, 2, 3. So as you can see, the carboxyl group is in the 3rd position. So let's see when we go this way. So when we go this way, 1, 2, 3, we can see that the carboxyl group is on the 2nd position. So in the rules of naming bicyclic compounds, we give preference with the lowest number. That's with the lowest number, with the substituent closest to the head bridge. So as you can see, this position is closer than this position to the head bridge. So we follow this way when naming this compound. So let me open up this compound. Let me change it from the skeletal form so that you will see what it consists of. As you can see, we have a carbon here, which is this carbon. This is the head bridge. We have a carbon, we have a carbon. We have CH3 here. We have CH3. This is a carbon. This is a carbon. This is a carbon. This is a carbon. So this is CH. This is CH2. This is CH2. This is CH2. So here we have another methyl group. Then here we have our carboxyl group. So you can look at the structure very well. So as we say, we start naming from here. So let's name it. Let's number it. This is 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. So what are the substituents we have in this bicyclic compound? We have a methyl group. We have a methyl group, and we have a carboxyl group. We have a carboxyl group, which is a ketone. This is a ketone. So let's name this compound. So we start with the methyl group. This carboxyl group will come at the end of the compound name. It will not come at the beginning. It's not like the halogenal group that come at the beginning. It's not a methyl group, so it will come at the ending. It will come with the parent name. So let's start with the methyl group. As you can see, we have the methyl group at carbon 1 and at carbon 7. So this will be 1, 7, 7 trimethyl. As you can see, we have the methyl group at carbon 1, carbon 7, and carbon 7. 1, 7, 7 trimethyl bicyclo. Remember, we put bicyclo because it has 2 cyclic structures. So bicyclo, this is 1, 2. Remember, we don't count the head bridge in this case. We ignore this place. So this is 1, 2. This is 2. In this side too, we have 2 carbons. 2, 2, 2. Then in the head bridge, we have 1 carbon. Don't be confused and say we have 3 carbon in the head bridge. We don't have 3 carbon. These are substituents attached to this 1 carbon. so it is 1. So 177 trimethyl bicyclo 221. So this is 7, which is what? Hept. So we say heptan. So this is where we include the carboxyl group, the ketone, heptan 2 on, because it is a ketone. It's a ketone, so we include on. So this is 177 trimethyl bicyclo 221 heptan 2 on. So this is simply what we know as camphor. This is camphor. So I hope you enjoyed the video. If you have any question, you can send us an email at doreadave@gmail.com. I repeat, doreadave@gmail.com. So you can do well to subscribe to our YouTube channel and click the notification bell so that when next we post a video like this, you will be notified. So thanks for watching.